All right, today we're not going to start today's lesson with today we're going to learn. We're going to start with something else. So this is your lesson. Deal with it. We're going to learn about interior angles. They are the angles on the interior, on the inside. You guys mostly or probably know this, but on a triangle you have 180 degrees. Okay, and we know that. We've learned it already this year, and we're going to kind of use that for all of the other shapes. This rectangle or a square, all right, a four-sided figure, it could be a parallelogram, a rhombus, anything with four sides is going to have two triangles in it. So this is going to be 180 plus 180, or we could say 2 times 180, which is 360. Okay, and we're going to kind of build our formula as we go, but we're going to use these examples. Now, when you're drawing diagonals, you always want to start from one vertice and go to the other ones that are opposite it. Okay, you don't want to just draw as many diagonals as you can. So down here on this pentagon, I'm going to start with this vertice, and I'm going to draw a diagonal to that vertice and to that vertice. All right, and then here we can count our triangles. We have one here, this is 2, and this is 3. So to find our angles in total, we're going to take 3 times 180. Okay, same thing for a hexagon. Okay, so we have 1, 2, 3, 4 triangles in there, so we're going to take 4 times 180. Okay, and this is going to be the pattern that we're going to use. Okay, the formula that we're actually going to use is we're going to take the number of sides, subtract by 2, and then we're going to multiply it by 180 degrees. This n minus 2, this guy here, is the number of triangles that are inside of that shape when you draw the diagonals. So if you look at a rectangle, four-sided figure, we have 4 sides. We subtract 2 from it, and then that means that there's 2 triangles in it. Same thing for a pentagon. We have 5 minus 2. Okay, that's going to give us 3 triangles, which is where we had the 3 here. For a 6, it's going to be 6 minus 2 times 180. So that gives us our 4. And it's just the same way all the way throughout. All right, so for this problem, first thing you need to do is find out what the whole sum of all the interior angles are. Okay, so we can count our sides. We have 1, 2, 3, 4, 5 sides. That means it's a pentagon. Although it's not a regular pentagon, which is all the sides are the same, all the angles are the same. It's just a pentagon. So we know that there's 5 sides minus 2 and times 180. Okay, 5 minus 2 is 3. That means there's going to be 3 triangles in there if I draw my diagonal. So 3 times 180 is 540. And then from there, you can kind of just add up all of the angles in there. So x plus 120 plus 110 plus 100 plus 130 equals 540. And then we have x plus 1, 2, 3, 4, 60 equals 540 if you combine all those angles. Subtract 460 from both sides. X equals 80. All right, so x equals 80 in this case. And they get a little bit more complicated, but the basic idea is the same. All right, so that's interior angles. We're going to talk about exterior angles here. Okay, well, on exterior angles, what we're going to do is we're basically going to extend the sides so that we can get one of the exterior angles. So on here, I can extend the side that way, and you're going to want to kind of keep the same method all the way around. I can extend this side, I can extend this side, I can extend this side, and this side. So in a pentagon here, we have 1, 2, 3, 4, 5 different angles. You can do it the other way. So you can extend them in more of a counterclockwise direction, so you can start and extend them out this way. All right, so you can extend it out so that you get them in either direction. It doesn't matter, they're all the same. All right, and what I'm going to kind of show you guys today is how this works. We're going to take all of these angles, and this isn't exact, okay? It's not, I guess, perfect. Just because I'm off a little bit, but we'll talk about the property here. All right, so if I take all of my exterior angles and I put them next to each other, okay, we have angle 1, 2, 3, 4, and 5. Those exterior angles, whether it's a hexagon, a pentagon, a septagon, it doesn't matter. All of these angles here add up to 360. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, they all equal 360. And that goes for any shape, okay? So the two things you need to know are the exterior angles add up to 360. The interior are n minus 2 times 180. Again, that is n minus 2 is the number of triangles that are inside of there, and then 180 is 180 degrees on every triangle.